Well, welcome everybody. My name is Mark Malincovic, and I'm the co-host for today's session. My role at Arango is head of product marketing, and we're blessed to have Michael Hackstein here, our chief architect. And today we'll go over beyond vector search, building trustworthy AI for production. This will be a great session for everybody. I just want to have a little bit of housekeeping sessions, if you will. We're on a new platform today. So if you'll see on the far right-hand side, there's a chat window, and we can converse back and forth there. There's a Q&A, and we'll also be having a couple of three poll questions. So we're just going to break up the presentation and just get some feedback from all the attendees in a couple of different areas. So with that, we want to just jump right in. So Michael, please tell us how to go beyond vector search and build trustworthy production AI environments.
Yeah, thank you, Mark, for the good introduction. And hello, everyone who is joining from all over the world for this webinar. I'm happy to present. And yes, so today's topic is going to go a little bit beyond vector search. So going from your toy project to actually make it useful and deploy it to somewhere where you can have a good project experience. So what is the general problem statement that everyone has right now when they are using large language models and try to do something with so-called RAG? So the use case is typically your team has a couple of documents that are scattered across multiple locations. May it be product documentation, websites, PDF files, maybe some customer contracts, or some technical stuff like specifications or design documents stored in Confluence. So we see different kind of document layouts, even in different kinds of tools. And before anyone did RAG, finding this information in this environment is a very manual and time-consuming process. First of all, need to know where all of those documents are that you need to look at. If you miss one, or miss one location, you are lacking some information. You need to read through those documents, and some tools allow you to search across them, but that's about it. Everything else was manual. Downside of current AI is the frontier large language models. They don't know anything, hopefully don't know anything about your confidential proprietary data. They have been trained on anything that is publicly available, but they are for sure not trained on your data. Also, your data must remain secure and confidential. We don't want to just hand it out to everyone to have frontier models be trained on it. Nevertheless, your answers must be accurate and grounded in the data that we have. And every answer must include citations so that we know the large language model has not hallucinated, but we can point to, okay, here's the source. And then, of course, the answer must be as complete as possible.
And we're certainly seeing the governance of AI rise dramatically, both in Europe as well as here in the United States. So that's a key topic.
Absolutely. We cannot just rely on something that our large language model tells us if we can't prove that it's not fully hallucinated. Okay, so first thing that we would like to introduce are RAG strategies. How are people right now solving this problem? What is the technical means to get there? But before we go there, we would like to start the first poll. So please take a minute, look at the poll and try to respond on where you are at your RAG journey right now. Are you still prototyping? Are you already in production, or is this just out of interest? Okay. So I think I will continue with the talk. Thanks to everyone who has participated. What are RAG strategies that people follow today? It all started with so-called vector RAG. So how would this work? We start from a question that a client has. Then we use an encoder to translate this question, which is natural language, human language, into something that is machine readable, typically a vector. And then we are trying to find similar vectors, so similar questions in the data set. Finding similar questions is not too great, so there are other techniques like hypothetical responses, which will actually get better results. But ultimately, what we are trying to do is we find a needle in the haystack on everything that is semantically similar. How do we get there? On the insertion part, we're starting from documents. They are chunked into pieces and then translated with an embedding into this machine-readable vector format. And then they are used in a vector index. And what this whole process does, it tries to find the most similar chunks, use them as a context for the large language model to generate your response. So VectorRAG, a little bit deeper dive, data gets chunked into smaller sections. Each section will get semantically searchable, and we can only find the best matching text sections. What VectorRAG does not do, we cannot find any kind of references or connections between different sections. What this technique allows us in addition is we can use it for some multimodal cases, namely images. So we can use the same VectorRAG technique to tell apart pictures of cats from pictures of dogs. Same technique, one is text, one is pictures. What are the database requirements here? Because I'm a database guy. Like, I work for a database company since 14 years now. And database requirements here, we need some vector storage, and we need to be able to find vectors that are similar. And that is done by vector distance. So we can find the other elements that are close to the question that I ask, or my hypothetical response to the question that I ask.
It's interesting, Michael. I guess when I look at Substack or Medium or even LinkedIn in different forums, this seems to be the starting place for a lot of folks these days.
Absolutely. This is the starting place where everyone started with, but it has some downsides. As we already have seen, we can't find any kind of connections. And people start to realize, and let me take this to one example where it is kind of obvious what this limitation is. So I assume everyone in the audience has seen a contract in their life. And typically a contract starts with an agreement. So this agreement is between two parties. And at this point, you will make an alias for both parties. One is, let's say, the client, the other is the vendor. Can be other aliases. And then every other section in that contract will only refer to them by this alias. So in every other section, let's say the license agreement, so the license expiration date, which I have on the bottom left, is done between the client and the vendor. If we now ask a question, when do we need to renew our license with Northstar, which is our client here in this case, or made up names, by the way, then we can easily find the first agreement. So we can find, oh, there is an agreement.
Yeah.
We potentially can also find the second section, but we have no idea if this second section is actually from this contract or from any of the other contracts we have, because this section, excluding the date, is exactly identical with all the contracts that we have. So therefore, VectorRAG cannot really relate the second section to the agreement it was shown in. And this is the limitation that the VectorRAG has at this point in time.
That's a key limitation, because I don't know if everybody saw, but I just shared in the chat the responses to the last poll, and 43% of the people are still in piloting mode. So as you're looking for your pilots, as we look beyond this section into GraphRAG and Advanced RAG, please pay attention, because this is a key architectural decision you're about to make.
Exactly. And one thing that you potentially don't even see in your prototyping phase. Because if you are testing the system with 5 different contracts, the chance that you accidentally hit the right one that was in your contract is real. You may get a good result, but as soon as you scale up to 1,000 or 10,000 contracts, this is going to be a problem that you won't see in your prototyping phase. So, what is the solution to this problem? And the solution is, or one possible solution is GraphRAG. So GraphRAG tries to identify the knowledge between different documents. It tries to identify entities that are written in those documents that we analyze and try to identify how these things are related. And this allows us to give a much richer context for the answer generation. Bit more deep dive. GraphRAG typically adds context to the semantic search by combining vector and graph technologies. We are still chunking the data into smaller sections, so we still have paragraphs. However, we are also building a so-called knowledge graph from those entities. We are identifying relationships between sections. We are identifying relationships even across documents. If you have 20 contracts with the same company, GraphRAG can connect those different documents as well. We can still find each section semantically, but now we can also follow those connections between them. And this allows us to actually use these for more advanced multimodal use cases, videos and movies. So what we can do with a video or a movie, we take frame by frame, index it with a vector to identify, okay, where is the main character? In which scene does the main character show up? And with the GraphRAG, we can now actually get the plot. Like, has the main character moved from one location to the other? Where has he met his enemy? And so on and so forth. These are things we can store in the graph side of things. Of course, this adds more requirements on the database side. We now need a vector store as before. But in addition, we also need a graph storage, which allows us to support traversal over connections so that we can identify relations between different entities. Going back to my contracts example, exactly the same contract. But with GraphRAG, we can now actually make this connection happen and say this piece, the license piece, belongs to the contract of North Star and Blue Peak. And suddenly, when we are asking this question, when do we need to renew the license? We can now identify from the contract, which is stating North Star, there was a section about the expiry date that was connected. And therefore, the large language model can reason and say, okay, the renewal date has to be before December 31st.
Perfect. Hey, Michael, I just wanted to interject as well as on your last slide when you talked about multimodal and the video example. Mm-hmm. For those folks that are interested in such a solution, Arango is actually part of NVIDIA's VSS, or video search and summarization blueprint. So in terms of being able to search and summarize, as Michael talked about, in terms of chunking data, it's great for things like training self-propelled automobiles. So the classic use case is we've all seen Teslas or whatever the case might be going down the street. How do you actually train that? So being able to see instances on that. And the VSS solution or blueprint by NVIDIA does that very, very well. So just wanted to share that little insight for folks tracking along.
Yeah. So if you have this use case where you are analyzing videos, so I think they have a public blog post about it, how they analyze sport games, so where they can actually follow where the ball is going, and if there was like a valid goal or if there was a foul before that was not seen by the referee. So these things are possible because they can track, okay, the ball has been moving from frame to frame.
Perfect.
Okay. But it doesn't stop there. So GraphRAG is another tool that enriches the context. And now we're introducing something that I like to call advanced RAG strategies, because I don't really have a class name yet, which is actually combining multiple RAG strategies or adapting to the user's needs. So it can have multiple input systems. So we have a vector RAG on one side, then we have a graph RAG on the other side, and we want to combine those results because we have different input data sets. We may need to do multi-step approaches, so making a good query plan and doing some deep research. And also these RAG systems tend to be part of an agentic setup. So where we have agents talking to other agents, where some of those agents have a RAG backend. And that is where we are hitting the land of full agentic AI. On the database requirements, it's still the same. We are just using the existing RAG technology, and we are making the query engine or the query agent much more capable on doing these things. Adapting to users' needs, I think I didn't highlight this properly. what could happen there is if you are asking basically the same query pattern, the agent could learn it and can anticipate the follow-up question. So on the contract example, when is the renewal date? A potential follow-up is what is like the customer's churn risk, or is there an opportunity to upsell the client? Because that's typically what you are trying to achieve when the renewal needs to happen. So the agent could just say, oh yeah, the renewal date is then, and by the way, this is the evidence for churn, this is the evidence for upsell, and like give you a good grading on how happy your client is with your services.
Perfect. So, Michael, we actually have a quick question here from Florian regarding GraphRAG, and I know we're now onto the advanced RAG, but I thought it would just maybe interject with some questions as they come along here. But can you use, or we, any embedding model in GraphRAG as you would use in conventional vector RAG?
Yes. So the thing is, the GraphRAG that I have been talking about is a combination of vector RAG plus graphs. We are still using the embedding classical for the vector to find the starting point. So we still want to find the best matching entities that we need in our queries. And then we connect those with edges. So we can absolutely use everything you know from the vector world to index the entities, and then have in addition everything how they are connected. Hope this helps.
Perfect. Thanks you for asking the question, Florian. Appreciate it.
Absolutely. And yeah, by the way, for the edges, we don't necessarily need an embedding model. Like they are just identified and found when we have connections between, but we are not following them semantically. We may sort them semantically after we have found the neighborhood of a vertex. So to make sure that we pick the right context from the graph. Okay. Good. So this is a quick overview slide, just to visualize. It has all been starting with a vector RAG plus a GraphRAG, which is a combination in my world. They are included in the advanced RAG strategies, hybrid RAG, and adaptive RAG. So adaptive RAG is adapting to the user's needs. And those, again, next level would be agentic RAG. So an agent can learn and adapt to what you're asking for, and an agent will, under the hood, use some RAG setup in whatever way. For the best quality, the highest context, probably a hybrid RAG approach. Okay, more talk. Now let's look at how we would implement everything. What I have not talked about yet are other technical requirements that I had on the very, very first slide. The technical solution so far was just how do we get our data? But we also need to make sure that we have the governance and the proof on how the AI reaches the response. Typically, we can do this by making sure we capture, okay, this is the graph traversal, this is everything that we have picked up on the way, and what we have used to generate the context in the end. We also need support contracts for all the software pieces that we are implementing and that we are using. And typically, there are some hidden complexities. I will present some of those later in this talk. So how can we mitigate those complexities? And another thing is, you're probably already at this point, there are so many options to choose from, which is the best one for me, and how do I actually evaluate which is the best one for me? Am I good with vector RAG? Do I need GraphRAG? Do I build everything myself? Like those are the questions we need to ask before we actually go into production. Then we also have requirements on the personnel side. We need development capacity for all the pieces. We need knowledge in the team for each component that we need to maintain. So if your graph database is down, we need someone who knows how to get it fixed. And therefore, the more components you have, the higher the total cost of ownership is. You need to buy licenses, and you need to have people that you need to pay that know how these systems work.
And Michael, we've certainly seen on the skills side the rise of semantics and ontologies, and it's become very, very popular over the last kind of 6 months. But it seems to be a big barrier for folks. So when we talk about the next section, it'll be interesting for folks to learn about autograph, I believe.
Exactly. That's the point. So the people on the right-hand side, every company right now tries to get those people.
Exactly.
So nevertheless, let's quickly look at how an implementation with a specialized solution for everything would look like. And we like to call this a so-called Frankenstack because it's stitching together different stacks and trying to make them work. On the left-hand side, we have the input data, which hopefully is a constant input data stream, because I hope for you that your company is signing new contracts from time to time. These new contracts we are going to store in the VectorRAG system and inside the GraphRAG system, but we now are in the need to make sure that those are kept in sync. And then on the right-hand side, we have an agent that needs to make sure if a client asks them a question, do I need to go to Vector? Do I need to go to GraphRAG? Do I need to ask both? So what do we need to implement? We need to implement the retrieval agent, which needs to do some multi-step query planning, orchestrate multiple calls to databases, and even generate queries in multiple database languages, because a graph query language is different from the vector store query language. And both of them, of course, are different from relational databases. So suddenly we need to generate queries for different tools, which is not too much of a problem because large language models are getting quite good at that. Nevertheless, we need to do it. And on the right-hand side, we will see the classical workflow. The agent first calls large language model, trying to build the query plan, starts to find the best matching sections, then goes to the GraphRAG after generating like some reordering and deciding, okay, this is the graphic query that I need to do. And finally, he has enough context to actually build a response. So it's a lot of workflow that we need to actually build and maintain ourselves at this point.
And then, Michael, I think you're actually being very polite and courteous here, as in if we were to deep dive into here, I'm sure there's pipelines and ETLs underneath all of this, and then there's the maintenance of this and the observability and how many places do you have to look for log files, and I think it gets a little more complex than this, but great illustration to kickstart the conversation around this classic Frankenstack.
Yes. So obviously that all comes with it. We need to make sure all these components get monitored, and we need to get the data in properly. So everything needs to be done. So what we actually want to do, going a little bit out, we don't really want to build this system. But what we actually want to do is we just want to take our enterprise data, put it in a magic box, which we call AutoGraph, which automatically builds all this knowledge graph for us, the vector indexing for us. So it basically builds a connected graph that grows with your data, because the AutoGraph is scalable to all the needs that you have. And on the other side, I don't really care which RAG strategy is used, as long as my response is responded to. So what we have there is an AutoRAG, which does an optimized retrieval and allows you to do deep search or instant search through the context graph that you have. And then it is connected with any large language model provider to give you a trusted outcome. So that is the thing we actually want to have. First want to drop in our data, got a trusted response, and don't care for everything in between. How does this actually work at ArangoDB? So the AutoGraph is the first piece of it, which allows us to set up all the data. It takes the documents, imports them, and creates a so-called corpus graph. So the corpus graph just knows what layout my documents have, how they are connected, but not yet on the entity level. And then it will build entities and communities for you so that we have a full GraphRAG or just a VectorRAG for something that is very, very simple on the dataset side. And with that, it sets up the AutoRAG piece where you can just ask your question. The AutoRAG is the agent that can figure out what is the best strategy for my question. Can I just take it from the VectorRAG? It's a simple response. Or do I need to do a multi-step querying approach using all the entities and communities to get this knowledge? And it even would stop as soon as it gets very confident that it has all the information in its hands already.
Perfect. And back to the earlier question around skill set. So this automatically is building your baseline ontology and building the knowledge graph based on the input for the ingested documents, correct?
Correct. That's absolutely correct.
Excellent.
So how would this single engine workflow look like? So this slide is the internal workings of the AutoRAG, or if you would build it yourself. So the retrieval agent is still doing a multi-step query planning. However, you now have the option to actually concatenate a query in a single access. And the reason for that is ArangoDB supports vector as well as graphs, as well as documents and full text, which we are not using yet in this case. But they are still there, you still have the option. So nevertheless, we only have query creation in one language, and we will actually get away with a single query if we want to. And on the bottom left, I have a shortened query of what it actually generates. We are looking for the best match in the vector storage side of the house, probably pick the top 20 matches, and then we go into a graph traversal on the knowledge graph, sort the result by some re-ranking mechanism, and then we have our context in our hand. So much simpler on the setup, less steps to do, less network hops, and less things that can go wrong.
The direct opposite of a Frankenstack.
Yes.
Would now be a good time for us to take the next poll, Michael?
Oh, yes. I think I forgot. The next poll is about how many systems you have in your system right now. Because I like to have one system that does everything for me instead of managing tons of systems. So let's see how it is for your journey.
Perfect. And I'll share the results for everybody like within a minute or two, just of everybody getting through here. So we'll share all this information with everybody.
Okay, then let's go on. So, but automation is not the only thing. Another thing that a lot of companies don't tell you about is error scenarios. Everything that can and will go wrong as soon as you put the thing live and put it in production. Typically, we are talking about a distributed system. So my use case is always not a toy project. I don't manage 10 contracts. Like we are managing 10,000s of contracts with this thing. So typically, we are talking about a distributed system. And in a distributed system, there's a chance for one component to be offline or lagging behind. And the larger the system is, the more likely we are in that situation. We are working under the assumption that we have a constant input stream of data. And we now assume that one of our database systems involved is slow or even refuses to write. What is the impact? Let's look at it. So we're looking again at the Frankenstack. And now let's move the document from the left-hand side into the system. So let's assume the vector-RAG is fast and it is working as expected. Then this document would enter the vector-RAG. And let's assume that the GraphRAG piece blocks or delays the write at this point. If now a client on the right-hand side asks a question, then it will be a little bit skewed because he will find now from the new contract that there was an agreement, but we have not yet stored the relation between it. The graph database has not yet stored it. So at this point, the agent does not know if the data is not stored yet, or if it's actually correct that this license agreement does not have a renewal date. So you can't really know if the response that the agent does here is wrong. It has very good proof that there is an agreement. But it has basically can tell you, I don't know anything about the connection. And that always happens if you are asking between two database commits. And it's your task to make sure that these databases are kept in sync. Now, let's make it a bit more complicated. What if one of the databases even refuses to write? So same situation. Again, the user asks. One database says, I don't have this document. So again, we are already in a bit skewed situation, but now let's assume one database does not write the document. At this point, we are in a data model skew, and we need to have a repair strategy. So we need to make sure that the piece that the GraphRAG in this case has just dropped needs to be retried without breaking the vector RAG. And I'm not even thinking about other contracts that have come in between here. But that makes everything even more complicated. If you instead use a single database in the center, we do have a single point of commit. And by this setup, we guarantee that there cannot be any data model drift. We have one transaction for this document covering vector as well as graph part. Document comes in, it gets delayed. If now the user asks, it's not there. Tough luck. But if the database writes, it is guaranteed that we have the vector as well as the graph data. So you either get the previous view, you're asking too early, or you get a consistent view of everything included. Write is either not visible or fully visible. What happens in the abort case? Document is not visible before the abort, and, well, it's not visible after the abort. So still the document is lost. We would need to reinsert everything. However, the client is not affected. Like, they have never seen this document in that system. They don't get a skewed response. So it's more consistent. Talking about repair strategies. So if that skew happens, well, I can just restore a backup and take it from there. Well, let's look at this. If we are doing backups, they are typically scheduled and automatic. So we do a backup like every night at 1 o'clock, for example. If like some late olds decide to sign a contract at 1 o'clock in the night, there's a chance that we are working on this contract. It enters the vector RAG. It's not yet in the GraphRAG part. And then we take the backup. Then at this point, the backup is actually skewed. And if we are restoring it, we have model skew. And the worst of this, we don't even know. Because probably a second later, the other database has committed, and the user asking like an hour later will never see that anything of this is skewed. We only see this after we are restoring this backup. And in order to repair this, we would need to know what caused the skew and would need to repair everything. So that's going to be tricky.
Yeah.
If we are using a single database in between, then there's a single commit, and we know for a fact that before this commit, the backup is consistent. After the commit, the backup is consistent, because the database decides, oh, I've seen this write, yes or no. And during this, I'm committing or I'm persisting something, the backup is delayed. So either you get it with the write or without the write, but both are still consistent, and there's no data model skew between graph and vector at this point in time.
Perfect. Hey, Michael, just before we get into here, I just want to interject. I apologize. I missed this question from, I believe it's Matoy, if I said that correctly. He had a really good question around AutoGraph. So we're going to go back a few minutes in time here. But the question is the AutoGraph, is this a component within ArangoDB or a product built on top of the raw database?
So that's a very good question. So this is a product that comes with our contextual data platform, which is a product that we sell as an SKU. We also do sell the database alone. And the database alone does not come with AutoGraph, but the whole AI suite that we put on top, which helps you build your all AI, like everything you do with AI, this includes the AutoGraph as a component built on top and using everything that ArangoDB offers.
Yeah.
So it's part of our product offering with the enhanced license.
And just to expand on that a little bit, so just everybody understands is so we changed from ArangoDB. We have a 10 years of heritage starting from 2014, And about a year ago, we changed the company name from ArangoDB to Arango, and our URL now is arango.ai. So we recognize ourselves as more of an AI company. And as we launched the platform about a year ago, we've now extended the capability. We have roughly about 20 AI services. So everything you're seeing in this presentation, GraphRAG, VectorRAG, we actually now are what's called a strong performer in Forrester's multi-modal data platform segment or category. So a lot of what's being shown here is directly integrated within the platform capability. So sorry for the talk track, but just want to put it into context as well. But now might be a good time also, Michael, if you want to introduce the next polling question as well.
Yes. So next polling question is, this is very, very important because we really want to help you make your AI journey as smooth as possible. So we are interested in what are your biggest blockers to trusting your AI's answers in production. Because from a database guy's perspective, I may have a little bit of a bias, but we want to make sure that we get your bias and solve the right things. So please participate in this poll and help us build the product that you actually need.
Fantastic. The responses are coming in here.
Perfect. Thank you so much for participating.
All right. Well, the whopping big one is 67% say they can't explain audit how it got an answer. So that's a big one.
Yes, that's also the one that we hear the most. That people will say, "Oh yeah, I'm asking the large language model, give it some context, and then I can't distinguish what has been hallucinated. I need to make sure that we have references back to the original one." And that is absolutely a built-in feature into our whole AutoRAG tool chain, so that the AutoRAG will exactly tell you these are the source documents where we have found the data that was used to generate this response. Perfect. So we have this tracing and we know exactly how your AI got there.
Right. Actually, there's the secondary one is too much engineering effort to maintain. And although we're not focused in on this from this webinar, we actually, I see you grinning, Michael. We come across this a lot. It's like a lot of IT organizations say, well, we can do that. And then, yes, you can, but is that really where you want to spend your resources, time, and energy? And why not build or partner with Arango that has it built into a platform? But we've seen, from Ravi, our CTO, CPO, talk about this as the 80-20 challenge. 80% of engineering effort going into maintaining the infrastructure rather than the 20% looking at innovation in terms of leveraging AI for new agents or applications. So we see this quite often as well. So this is actually a really telling poll. I really like this one a lot. And I'll put all the answers. They've definitely moved around since I've talked about them, but I'll put all the answers in the chat here as well.
Yes. So as Mark said, those are the things that we hear very, very often from all our clients. And exactly those were the pain points that we try to solve with this whole AutoRAG autograph. Like making everything as smooth and easy as we can from our side for you to consume, and then also make sure that we are using as few systems as we can so that the effort on actually maintaining them is as low as possible. And this also is an advantage of having everything from the same vendor, because all our monitoring is checking on the autograph AutoRAG level. So we make sure that the full monitoring tool fits together. If you are combining several systems, you need to monitor and have a full monitoring setting for one database and then for the other, and somehow make sure that they relate to what you're looking for. So these informations, you need to maintain yourself and need to figure out how they impact each other. And with the AutoRAG tool, that will just be out of the box because that's what it was built for exactly this flow.
Perfect. Now with this, I think we have I think we're just at the point of wrapping up. So I apologize for interrupting, but I think sorry, why don't you take it to the end here, Michael? My apologies.
So the end is there. So I'm done with the content. thank you all so much. If there are any further questions, I'm happy to respond.
Yes, and just to let everybody know, so in this platform on the right-hand side, you'll see a tab for resources. And one of the resources we're offering today is a digital ebook that will outline the 6 requirements for a contextual data layer. So the output of Arango's contextual data platform is giving you the tools and workflows to create context within your organization, to bring together, semantic clarity, temporal instances in terms of time travel, etc. So if you want to read more about how we do that with the basic 6 requirements, there's many more than that, but those are the fundamental ones. Please hit the resources one. And I think the team wanted to have one last poll up here. If you look at the last polling question, if folks would like to meet with one of our experts and have a tailored demo and a more of a workshop environment to dive into your needs, please just select yes, and we can get that organized for you. We'll keep that open just for a couple more seconds. If you need any other resources, if you visit arango.ai on our main menu, there's a Learn tab, and that's where all our blogs, our technical resources, ebooks, upcoming events. And we also have a meetup. If you want to go to meetup, we are AI contextual, our context builders, and we're actively building our community for folks in data, AI, and obviously within the data platform environment. So with that, I'm going to wrap it up. Thank you very much for everybody joining us here today, and we'll follow up with the recording. And if there's any other questions, please reach out to us. Have a wonderful day. Thank you, Michael.
Thank you, everyone.